Hello everyone, this is Soundarya from Sri Venkateshwara College of Engineering, currently pursuing my 8th semester in CSC department. Today let us discuss about Raspberry Pi, which is one of the topic of IoT. IoT means Internet of Things. Now let's see what are all the contents of the topic which we have taken. These are all the contents which we are seeing today. Introduction of the topic which we have taken, hardware layout which is present in it, and operating system, configuration to programming, wireless monitoring, temperature system. Next, let us see what is introduction of this. As you know, Raspberry Berry Pi is defines as it is a debit card sized low cost computer that connects to a computer, desktop, or a TV and uses a standard mouse and a keyboard. It has dedicated processors, memory, and graphic drivers just like PC. It also comes into the operating system Raspberry Pi OS, a modified version of Linux. It is a powerful low cost device and power to revolutionize the way we interact and engage with technology. As an introduction of IoT, it provides users access to millions of connected devices that allow automatically many everyday tasks while gaining insights into our life choice that are data analysis. With a small factor, user-friendly environment and affordability, this tiny computer has been quickly adopted to developers, business, and hobbyists alike as one of the favorite platforms for exploring what's possible in the internet connectivity today, from controlling smart home appliances or security systems remotely from anywhere in the world using the phone or laptop, tracking medical equipments, reading via wireless sensors, mining cryptocurrency as the part of distributed networks. These are just some examples that you can leverage on Raspberry Pi when introducing the yourself into the IoT landscape. This is one of the uh, thing which we are using, like giving the input for a TV or a desktop to connect each other. For that purpose we use this. And what are all the hardware left in this? We have Raspberry Pi board, which is a main hardware device which we are using. This serves as a central computer unit, which is also called as a CPU, and runs the operating system OS and the application software. These are several models of Raspberry available, each with very capabilities and features. Common models include Raspberry Pi 4, Raspberry Pi 3, Raspberry Pi 0. Power supply. The Raspberry Pi requires a stable power supply to operate. Debugging on a model and peripheral connected power requirements many vary. A micro USB power adapted to the USB-C power adapter commonly used to provide the power to the Raspberry Pi, which power supply. Then micro SD card. This is the which contains the operating system like Raspberry Pi OS application software. The micro SD card serves as a primary storage for the Raspberry Pi peripherals which are there. Various peripherals can be connected to the Raspberry to enable specific functionality in the IoT application. Some of the common are sensors, actuators, and communication model sensors, which are the temperature sensors, humidity, motion approximate sensors connected Raspberry Pi connected to the environment. Then we have actuators such as LEDs, motors, relays, servers are connected to this physical devices to perform action based on the sensor data. Then communication models such as Wi-Fi adapter, Ethernet cables, Bluetooth dongles, and GSM 3G, 4G modules enable the connectivity of this IoT devices. Next, we have a expansion board, a facility of connection to a peripheral and provide a additional functionality. Expansion boards or halt hardware attached on the top can be used. This boards typically stuck on top of the periphery. Raspberry offer features such as additional GPOI pins and analog input specific sensors, interfaces, enclosures, depending on the deployment environment and the application requirement on enclosures may be used to protect the Raspberry Pi. Its components from dust, moisture, and physical damage. Connectors and cables, physical connector and cables such as jumper wires, ribbon cables, USB, etc. are there. Then cooling is solutions in some of the cases, especially when using high performance models in the Raspberry or operating system. High temperature environment will be present. At time we will use a cooling solution for this. This is a diagram of this is a one of the model of what we are using hardware layout. This is the board, these are all the sensors, and this are the actuators, and all present. As we can see how many volts which are present here, and also it is represented. Then we have a operating system which is a OS, which is the main part of the Raspberry, means which we are using. Raspberry is formed. Raspbian is a Unix-like operating system based on the Debian GNU Linux distributed for Raspberry family compound and single board computers. As we can see, this has a the Linux which is used here for the components which we are using. These are all the components which are there, softwares which are used in the Raspberry Pi, like operating systems like OS MC, as we seen in the slide, Backoterian Linux, Mterian, Windows IoT, Laka, Pop, OS Twister. This are all there. Then we can also observe more here how this Raspberry is present. Next we have we can install this manually as shown in the image by going to the browser, which we can select either we need a Mac or a PC, which we need, and we can start downloading it, and where this will be act as an input for the device which we are using, means app which we are using for that. It is like a keyboard or a mouse, like that. It helps for this is mainly a Linux based. Then it is changed into, it can be also used in the Windows or PC, in anything. Next one is, we'll see what is operating system is done. Configuration of programming. Configuration of programming in Raspbians. We are using Raspbian with the Pixel desktop. It is one of the best way to Raspbian started with a Raspberry Pi. Once we finish booting, we will be in the Pixel desktop environment. Now to learn the menu, you need to click the button that has Raspberry logo on it, and this button will be in the top. After clicking the button, choose Raspberry from the performance. This model we can see here in this one. This is a performance. This is made up of pixels, number of small. Here we can select which we need. We have to change. This is one of the Raspberry which we are changing here. This is one of the input which is given. It changes and we can name it as Raspberry. After, if we click OK, it will change, modify, it will be modified, or else if cancel, nothing will be modified. It will be either how it is earlier, change password, host name, everything, the description of it is given here. Then we also, this is like a Bluetooth device configuration and data participant setups we can do. These are all some of the things we have seen here. Next we have wireless monitoring system. Raspberry works as a base station which connects the sensor nodes via Zigbee protocol in the wireless sensors networks and collects sensors data from different sensors and simply multi clients services including data display. The client can visit the base station and remotely via a website or internal command. As we know, we can give either outside command for it, or else we can configure it as given. This is a simple which we can see here. This is the Raspberry station which is using Zigbee protocol and also wireless sensor network protocol, which collects all the data sensors. As we know here, the sensors actuators which are present here will try to collect all the data here. We have seen this, we have seen cooling solutions, sensors, actuator, communication models. These are all the some of the peripherals of Zigbee and control systems, which tries to control all the data which is there and helps for monitoring the system. I hope you have learned something new from this video. Please like, share, and subscribe to my channel. Thank you.